part 5 of Unit 9. Please start by turning to your table of contents. And today we are going to continue and finish page 9. And so add today's date to your page 9 spot, and then you can turn to page 9. We are going to pick up where we left off on that page. It's partway down the page about viruses. All right. Now, a virus is super small. Smaller than a cell, way smaller than a cell. We need something called an electron microscope to be able to see them. This is a picture of a virus from an electron microscope. Way smaller than a cell. Remember, we could see cells at about 100x. Even on our 40x on our microscopes, we could see cells. To see a virus, this is probably 10,000x to be able to see this or more. They are not made of cells, and as a result, they are not considered an organism. They are not made of cells. However, they are made of some things that you find in cells. They have genetic material in them, and some of them have DNA, and some of them have RNA. And then they have a little coat of protein over them, and the protein coat is going to be have the antigen. That's going to be the little name tag. Remember, we talked about it having the antigen being the name tag saying what it is. That's this protein coat. It's the name tag, basically, that is saying what kind of virus it is. All right. So let's start with DNA viruses. A DNA virus, of course, DNA stands for deoxyribonucleic acid. You already know that. If we're calling it a DNA virus, it means it has a virus core that is made of DNA instead of RNA. When DNA viruses reproduce, and they go through this active virus state that you're going to learn about in a little bit, it makes exact copies of itself. It very rarely will mutate, but will instead make exact copies of itself. Now, the reason this is significant, why this is important, is because as we try to fight viruses and prevent them, it's much easier to make a vaccine for a DNA virus because they rarely change. We know what to expect from a DNA virus. We know what it's going to look like. We know what the DNA code is going to look like. We know what the antigen looks like. So some examples of DNA viruses: the chickenpox virus, the smallpox virus, the polio virus. These are all DNA viruses. And DNA viruses are ones that for many of them, have really good vaccines for them. We have vaccines that are super effective and continue to work year after year, decade after decade, and they help prevent us from getting these diseases. All right, now an RNA virus is a different story. RNA stands for ribonucleic acid, and a RNA virus has a virus core that is made of RNA instead of DNA. Now, the tricky thing about these is that this kind of virus very easily mutates over time. So it's constantly taking new and different forms. So remember that a mutation is a mistake or change in the DNA copying, right? So when we have a mutation, it means that there's a change in the code when it reproduces. And this makes vaccines for these really tricky, really difficult, because they're constantly changing. And so some examples are cold virus, flu virus, HIV. These are viruses that are changing all the time. And so you'll notice, of course, these are ones we do not have good vaccines for. We certainly try. The flu virus is one that every year they put together a flu shot. And the flu shot is really a collection of several different vaccines put together. They make their best estimate of what they think is going to happen with the flu that season, which forms of the flu might be most likely to be out there, and they try to prevent those. But you'll also know sometimes we have flu shots that don't work very well, and that just means that the flu ended up being different than they were expecting that year. So that's because it's an RNA virus. It's constantly changing. They don't know what's going to come up in flu season. They just have to do their best research and try to predict it. Okay, so we're going to do our Cornell notes here right away. If you'll grab your highlighter and highlight your keywords here. We're going to do 3 questions with 3 different question starters. And for your summary, you're going to compare and contrast DNA and RNA viruses. You can choose to do a 3-column comparison, like where you have a both column in the middle. You can do a Venn diagram. If you do that, try to make it nice and big. Or you can write it in paragraph form, explaining some things that are similar and some things that are different. Please pause the video right here until you are done writing. All right, before moving on, please double check you have followed all of the instructions. Make sure you've highlighted, make sure you have 3 questions with 3 different question starters, and make sure you have a complete summary that is comparing and contrasting these 2 types of viruses. Please go to your score sheet now, and I'd like you to add assignment number 5. You can see for assignment number 5, we are going to include pages 7 and 9 as one stamp. So before you come up for the stamp, make sure that you look carefully and make sure everything is done on both pages 7 and 9. When you're ready to go, please stop the video and then go up and get the stamp for pages 7 and 9. And that's the end of part 5.